Hi guys, welcome to TechoGenius Academy. We are industry-led training providers for those who wants to build their career in data science, analysis, IoT, device driver, embedded Linux and many more. Please do like, share and subscribe to our channel.
Hello everyone, welcome back to the TechoGenius Academy. Today we are here to discuss the next session in Linux system programming. Now people are more engaged in learning Linux device driver programming, and we have uploaded much information about that. And recently we have just uploaded the new series in Linux SPI device driver, and which is readily available in the website, and you guys can just go over there and avail that. And today I just want to discuss about the synchronization technique, because few people just send me that messages that we are getting difficulty where we need to use the shared memory and semaphore together. So as you know that we discussed about the semaphore concepts and all in our earlier sessions, so where we discussed about that how a semaphore works, and basically it allows the processes to synchronize their action, and it just synchronize the block of shared memory segment just to prevent one process for accessing the shared memory at the same time where another process are updating that. Okay, so it's a kernel maintained integer which you already know, and it's a communication between the two processes and all. So today I just come up with the some advanced programming where what we will do, we will use some of the shared memory calls and some of that semaphore calls to synchronize between the two processes. So basically it's you can say it's a full duplex communication where we can use fork system also just to create the different process and all, and just to create the child process. And without wasting any time, let's get started. So because whatever the calls we will use, we will just see in the man page 2. Okay, so I just don't want to add those stuff and all, because it's already readily available in that man page. So let me go to the terminal directly. Let me just create one directory here, and we can say sync shared memory and semaphore.c process 1. .c. Okay, so first of all I just need to get some of the header files. Okay, hash include sysipc.h, sys/shm.h. Let me just include each and everything. Okay, let me include for semaphore 2. Let me include some of the header file also. This is pretty much good. Now our next step is to start our main function here and declare the two pointers, because we just need to do the full duplex communication. So for that we need two shared memory pointers. Okay, so if we can say here the shared memory, this is for process 1, and shared memory pointer 2. Okay, now we need to we need to declare the ID also, the shared memory segment ID and the sem ID too. So because we need to initialize both the IDs just to access the segment, you can say. So int shm ID and the sem ID, and as you know very well, if I can just go to sem op, so you can see here there is a structure sem buff. Okay, so the sem buff structure will have your sem number, sem op and sem flag, and we already discussed about that. So it will do some semaphore operations, so we need to declare the sem number in this session. So what we will do, we will just declare that to struct sem buff. We will just declare as v. Now we just need to use the shm get, you know already, because I have already explained you in the other session. So it returns the identifier of system v shared memory segment and associated with the value of argument key. Okay, so it will give us the shared memory ID, some key. Okay, so let me just use the variable here and the call shm get. Let me just first one, the key size and the flag. So we are just creating that, and let me just take key as some 4, size as some 50, and IPC create. So this is the permissions. Okay, this is good. Now we need to allocate the memory address. So how we can do that? We need to attach the shared memory segment. So by using the shm80, as you know very well, so the shm80 attach the system v shared memory segment identified by the shared memory ID to the address space of that calling process. Okay, so first one is the ID, that second one is address, and the flag. So if that SHM address is null, the system chooses a suitable address at which to attach the segment. So one second, what happened? One second. Okay, so the first we will just create for pointer 1 shm80, the shared memory segment. First one is the SHM ID. We will pass null, whatever the suitable address it will be there, it will just allocate that memory address. Just we can say allocation of memory address, correct? Now we just need to make this memory 0. So just because like we don't want to take any risk, so we will use the B0. So it will just write the 0 value string, like 0 value bytes, it will just write to that. Okay, so we will use this, and similarly for pointer 2. This looks good. Now we need to create the semaphore. So how we can do that? Using semget. So the semget system call returns the system view semaphore set identifier associated with the argument key. Okay, a new set of number of semaphores is created if key has the value IPC private, or if no existing semaphore set is associated with the key and IPC create is specified by the sem flag. Okay, so let me just create the sem ID semaphore. Yeah, so we will create the semaphore here. So it will return the sem ID semget. Here I'm using 4, creating 5 semaphores, and I'm using IPC create. This is pretty much understandable. Great. Now your work is to add the error condition here. So I'll give you some task here. Declare the error condition. Okay, now first thing is we just need to use the fork call, which will create the child process. Okay, so this will be your parent. Okay, now what we need to do? First of all, we need to set the structures sem of members. Okay, so sem number, the first we will just make it 1. Okay, and sem op equals to 1 second. Okay, so the sem op will make it as 0. We don't need to, it's just like we just need to put it like as a positive value. Flag we are not using, as it is we will put that. Now the next thing is if we are scanning here. Okay, so if we are scanning here, we need to print into the other child process. So what we can do here? So we need to put some lock here. So semaphore, you can say like the one is updating the stuff and all, other has to wait for that. So what we will do, we will set the lock okay, and we will scan it. Okay, whatever the data, whatever the string we need to put into that other process, so we can scan here and we can print into that other process. For that we need to lock the other process here. Okay, so the first thing is we will, whatever the operations of the structure sembuff, we have put that, so we will include that using the semop operation. And the semop operation, as you know very well, the semop I can show you again. The first one is the sem id, okay, and the other one the structure, sembuff structure, and the number of you can say operations. So as you can see, all this stuff is written over here. So let me just go here and include the sem id, and the structure, and 1. Okay, now what we need to do, we need to set the lock. semctl is used for that. Okay, so man semctl, so it will control the operations and all, so specified by the command cmd. Okay, so I have all the details. The first thing, I'll just put sem id, okay, the sem number I'll just put here. I'm putting the sem number as 1. The other here, other is like, I'm just putting sem number 2 just to communicate with this. We will just use the command set value, we'll just make it as a 1. Okay, we just set the lock, okay. Now we need to scan it. What we need to scan, we need to scan the shared memory segment here. Okay, so this is pretty much good, understandable. Okay, and what we need to do here is we need to use the semctl just to open the lock. Sem id 2, set val, 0. Okay, so this is pretty much good. You can say open the lock. Okay, so let me just put this stuff like printf, enter the string, this will be in the while loop. Okay, this is pretty much understandable. Now if we are using for this scanf, this the sem number is 1 and 2 we have used. Now we need to use 3 and 4. So if we are scanning in first sem number, so the other scan we will do it in the another process. like in another program, and here we will use the you can say the print. Okay, so for that let me say, like, if that is 3, this will be our number 4, number 4, and sem op will be 0, and we are not using any flag, so it will be 0. Now what we need to do, we just need to use the same stuff here. What we can do here is y to initialize again and again. If I can say like this, this will be also fine. Okay, okay, and similarly for this one again I am rotating the loop. And if I can say here, I have to set the which lock? I have to set the third lock. Okay, and we need to open it. Okay, and we can say here is data, okay, and the pointer 2. Okay, so this is pretty much good and understandable. Okay, let me just do the indentation. Okay, this is pretty much good. Let me just run this, just compile that. Sync p1 sync 1, okay, -o. Great, we got that. And now let me just copy this same file to p2. Okay, let me just open this p2 file. There is, like, we need to make some changes in the another process, but rest of the things will be same, and we just need to concentrate on this one, this part. So now starting from the if part, in that another program, there we were scanning. Okay, so here what we need to do, that number was 1, this number will be we will make it as 2, and we just need to set the lock. We'll make it as 1 and we will make it as 1. Okay, and yeah, this is pretty much good. And for another one, what we were doing for another one, if we are making as 4, we need to make it as 3, and we need to set the lock for 4. Done. So this is pretty much clear. Yeah, we have done the good work here, and now what we will do, we will just execute this also. Great. Now let me open the another terminal here, and this one. Okay. So I just need to show you in a more generic way. Sync 1 and sync. Okay, CDLSP sync 2. Okay, 1 second. Okay, this is good. Now what we will do here, we will just enter TechoGenius. Okay, hey, okay, there is some issue. Let me just check it. So we are not able to print it. Okay, vi sync p1. So how we can resolve this? We are setting the lock, we are scanning it, and will it help if I'll do the self lock here? Like it will not go out, so we just lock the second process, but we are not waiting it here. So if we can self lock here semctl of this first semaphore sem id, and if we will set the value as 1, so if we will do the self lock here, then will it be any chance so we can get the value correct? So for this 4, okay, great. Let me just do it here also. For this 3, and for this 2. Let me just try once if we can successful in this. Okay, sync 2, sync 1. Hey, okay, no, we are not getting it. We just need to try another stuff also. Let me just check, like, if I miss something. Okay. We are making it correct in a correct way. So in an else condition, we are creating the same number, address of v. Okay, we are setting the lock. Okay, each and everything we were doing correctly. Just 1 second, I just need to try some stuff here. Okay, I'll just try the error condition also, because if this fails then there is some issue, because I have not declared the error condition now. If SHM ID is okay, SHM ID is less than 0, P error SHM get and return. Okay, and for SEM ID, okay, okay, let me just copy this and paste it here. Will not do. Okay, okay, we are not able to print, we are not able to communicate. Okay, just hold for a second, I'll just see the issue. Yeah guys, so I have checked that. So that it's it's just a silly thing. So we just forgot to mention the slash in here. So if the slash n is not there, it will not print. So there is no issue also if will not write the self lock here. So rest of the things are quite similar, so there is no issue in this. So I can just execute. So I can just show you the other program also. So I've just undeclare. So I've just comment this self lock stuff and mention the slash n here. So can we just execute this? So if I'll say hello, so that will print, and if I'll say here TechoGenius, so it will print here. So your task is to print the string like, hey, my name is Ankit. Okay, so if I'll say enter here, so it is printing is Ankit only. So why it is printing like that? So if it's like four thing, I'm like 4 words, I'm just printing it. It's just printing here the last one. So why is this? So you just need to find out. If you are not able to do, I'll give you the solution. Okay, so hope you like this session, and I just want you to practice this type of communication, this type of advanced session where you can include the semaphores, where you can play around these calls. Guys, we have not used, as you can see here, we have not used any flag, we have not used any SEMOP operation. So you can add those flags, you can use it as a locking mechanism and all, and you can try to write into that file, because I'm just communicating between two processes and all. So suppose like there are multiple processes who can who are accessing the some file and all, so they just want to update it. So how it will update, how it will indentate those stuff and all. So it will add at the end, and if the data is not adding it properly, it will corrupt it, or maybe it will overwrite. So you can just play it around. So in that way only you can just understand the basic concept behind that. Okay, so that's it. And further, like what I will do, we will do some extra advanced topics in Linux system programming also. And till then, if you like this session and all, I just want you guys to subscribe and share it with your friends and all, so others can also get benefited. So thank you so much.